Like I said, thank you everyone for being here. I'll be explaining my project, Jazz Music's Effect on Visual Spatial Ability, and I'll be beginning with a little bit of background on the study I got the most inspiration from, and I'm sure most of you have heard of the Mozart effect before. The 1993 study proposed the idea that listening to Mozart improved the cognitive performance of students. It has been one of the most well-known music-related phenomenon since then. However, it's often not noted that the improvement was on a very specific cognitive skill, not general intelligence. Despite this, the public still holds interest in this, often resulting in parents trying to ingrain classical music into their children's brains, like the CD you see on the right side of the screen. And for those of you who don't know me personally, I am a pretty serious musician, so I was one of these cases. I played classical piano for my whole childhood, and now did music really make me smarter? I actually don't know, but hopefully we'll find out today. There has been extensive research on music neurology with various works from different classical eras and composers, and past studies have examined the comparison of performance in cognitive tasks and test scores with and without music. Although these experiments are well documented, conclusions and evidence can often be ambiguous. Despite this, it's logical to say that listening to music has some sort of effect on the brain. In the Mozart effect, it was unclear how music enhanced cognitive performance, but researchers speculated that the practice of listening to music acted as an exercise to help organize nerve cells in the right half of the cerebral cortex, which is the part of the brain that's responsible for higher functions, and different forms of music are proposed to activate selective brain cells, allowing them to process information more efficiently. One common finding among the various studies is the improvement of visual spatial ability. This is defined as the capacity to understand and remember spatial relations among objects. For example, this is the cognitive skill that you will need to construct a puzzle together. In order to successfully complete this task, you will need to be able to visualize how the different pieces might fit together. And obviously, puzzles are designed for different ages and increase in difficulty as the targeted age group gets older. And that being said, this cognitive skill is developed as one matures in life. So it makes sense that different puzzles vary in difficulty by age. However, visual spatial ability is much more than just childhood puzzles. Some of the real-world puzzles call for the skill as well. It is extremely important for success in many fields of study, such as math, natural sciences, engineering, and architecture. For instance, astronomers must be able to visualize the structure of a solar system and the motions of the objects in it. More than ever today, visual spatial ability has been increasingly important with the development of new technologies such as imaging, computer graphics, data visualization, and supercomputing, all being highly demanding spatial tasks which involve the construction of mental representations. It's undeniably one of the most valuable cognitive skills for future generations. So yes, even if the Mozart effect only improved just one cognitive skill, this specific one is definitely worthwhile to try and analyze to see how can we optimize this. So real-world situation, despite the lack of visual spatial ability, despite the importance of visual spatial ability, school curriculums are often geared towards training linguistic and verbal learning. So there's often a lack of the practice and development of visual spatial skills in youth. And this possibly could be a missed opportunity because this is when the brain's plasticity is greatest. And furthermore, the traditional schooling system often enforces one specific verbal thinking style, which you can see on the left visual, and this leaves visual learners at a disadvantage. It's very evident that there's multiple styles of thinking, and it varies between each individual. Personally, I see myself as a visual learner, and in schools, this has raised controversy with things such as the College Board SAT, and in which verbal thinkers outperform visual thinkers significantly. This is because visual learners tend to approach tasks holistically or non-sequentially. However, this method tended to be at odds with the typical academic curriculum. Especially in real-world school, this is a huge disadvantage for visual learners because they think holistically or non-sequentially, they might miss out on the steps that may be required for credit, like showing your work in math class. And that being said, I feel that it's super important to find ways to exercise our visual thinking skills as much as possible because it's simply not catered to in school. Though we might not be able to change the schooling system, we can take small steps that may help us personally. And in my study, I found that something so small, such as listening to music itself, can be an exercise for our brain. Neurobiology of music is a highly specialized field, and there have been many studies which have shown music to have various aspects of health. The beauty of music is that it's a universal art and language, so it has allowed people to express their feelings in every era of human history all around the globe. It's a universal language. And several studies have even supported the claim that music has the ability to reduce stress in both small inconveniences as well as life-threatening situations. I'm going to talk about a study real quick. So a study from New York examined the effect of music on surgical patients and recorded data that suggested that music caused an average reduction in blood pressure levels and heart rates. So if music has the ability to reduce stress in these life-threatening situations, perhaps it also has the ability to reduce stress in schools. Even more so, maybe a genre that is specifically known for smooth, relaxing music would be even more effective. So how does our brain react when we listen to music? Music interacts with multiple regions of the brain and interacts with them all differently. So when an individual hears music, there are multiple processes in which the brain goes through. It begins with the sensation of hearing, which is processed in the temporal lobes behind the ears, and this sensation is then transferred to cognitive lenses, which attach meaning to the music based off of previous experiences. This is the reason why music has the ability to evoke such strong emotions in humans. Also, certain tempos appeal more to different emotions. For example, hip-hop is a common genre for exercise and workout playlists because the upbeat rhythm can be energizing for athletes, therefore increasing motivation for better performance. Heartbeats generally sync to the beats of the songs an individual listens to, so the closer the music is to 60 beats per minute, the closer an individual is to the sensation of relaxation because of the slower and calmer heartbeat. On the other hand, the closer the beat is to anything over 120 beats per minute, the more energized one will feel as the heartbeat will increase. And however, calm music is assumed to be more beneficial than exciting music when the brain is put up to the task that requires an individual to be relaxed, such as studying. This is the process of calming the limbic system in the brain. The brain does something similar to the heart as well, and it does this through binaural beats. So actually the brain and the heart work together, and it's suggested that the frequency of brain waves can gradually change to match the frequency of binaural beats in a song. Binaural beats are often used to achieve the effect of being in a calm yet alert state, and these beats are a tone created in the brain when presented with two different beats at the same time. This has the ability to actively induce a state of relaxation when the brain produces more alpha waves. It is also suggested that the increase of alpha waves increases relaxation, concentration, memorization, and can even reduce depressive symptoms. And there have also been studies that suggest when music matches the frequency and BPM of alpha waves, it has the ability to slightly enhance the ability to learn and remember new information. So this is ideal for schools. So after all this background research, I wanted to address the gaps of knowledge I found. In general, music neurology is an extremely specialized field, and there are little to no studies regarding the effects of jazz music on cognitive ability. In addition to this, there are barely any studies on adolescents. When working with minors, it's a lot more work to get things done, such as consent forms, because they're minors. However, I thought this was very worthwhile because visual spatial ability is crucial in brain development, like I mentioned earlier. And this also provided relevance to Iolani's situation today. And one of my goals was to help the Iolani community. And that being said, the purpose of my project was to address these gaps of knowledge and utilize these past studies. So I formed the research question: does jazz music improve cognitive performance in visual spatial skills in adolescents, more specifically Iolani upper school students? My experiment, in simple terms, would see if listening to music could boost test scores that measured visual spatial ability. So I obtained a test, or a standardized test called the MASME, which stands for the Measure of the Ability to Form Spatial Mental Imagery. This was created by Dr. Alfredo Campos, who was kind enough to give me full access to his assessment for free, so thank you for that. And it is a 23 question or multiple choice question examination, and participants were given 10 minutes to complete it. So as you can see on the screen, there's an example question, and each question utilizes the layout of this cube. And in order to gain full credit, the participant had to select two answers that were possible configurations. So you can look at the example and see if you can figure that out. But all students, regardless of age or grade level, took the same tests. So it was the same difficulty for all the grades. So of course the scores varied, but then each participant took the test twice. So the main thing was seeing their improvement or if they did worse. So the first time was like a baseline test for everyone, and in the second round, individuals were divided into experimental and control groups. So to restate, the baseline test was everyone taking the mass meet in silence, but in round two, the experimental group listened to jazz music in the background while the control group took the mass meet in silence again. This was to show the effect of just taking the test for a second time. Since the testing period was only 10 minutes, I only needed 2 songs, so these are the 2 song selections I chose, and these are from jazz standard repertoire, and it's also important to note that these songs are both played at a slow tempo, so they're both pretty close to 60 beats per minute, so meaning there's a greater potential for listeners to feel relaxed, which is the goal overall. And also, these songs are purely instrumental, so there's no voice singing lyrics that could possibly distract from the testing. And in previous studies that I researched, there is the possibility of a listener to be distracted to lyrics. So in like pop music, they may be, or let alone from the tempo that might make them feel anxious. The lyrics on top of that might have the effect of distracting, but I will talk more about that in the end for future studies. And just for your reference, both of these songs are 60 beats per minute, so that is how fast a clock ticks. When I first designed this experiment, I was pretty unfamiliar with statistics, so I made the mistake of creating unequal groups. So I put 30 people into the experimental and only 10 into the control, but I later found out that I should have done 20 and 20. Nevertheless, though, I was still able to draw conclusions from my data. And in addition to this, I was very lucky to be able to do a second session of testing in which I tested 100 participants and divided them up equally. And I also had greater diversity for ages and grade levels. Since each person took the baseline test and a second round test, I calculated the difference in scores, so MassMe2 minus MassMe1 would show the improvement. And from then, I calculated the mean differences for both the experimental and the control group. So this is session 1, and for your reference, we'll be looking at the top parts of these charts. So in session 1, my group had an average improvement of 3.2 points, which is equivalent to about 1.5 questions. So while the experimental group had an improvement of 12, which is like 6 questions. So just to restate, the control group is the one who did not listen to music. So that means that the 12-point improvement came from the jazz treatment group. You can see that it's much greater. So in my statistical analysis, this was necessary. I used a t-test because I was comparing the difference between 2 means. So my null hypothesis was that there would be no difference between the groups, meaning that the control and experimental differences would be identical. My alternative hypothesis was that there would be a positive difference between the difference in test scores, meaning that the jazz music would have some sort of positive effect on the performance. And luckily, I was able to reject my null hypothesis and assume the alternative because I had a very low p-value, which was low enough to declare statistical significance. This essentially means that I'm 99% confident that the jazz group had a greater improvement than the control group. And because both experimental and control groups took the test in the same conditions, it is very likely that jazz was the factor to change this grade difference. So to restate, in session 2, in my session 2 data collection, I included way more participants, so I went from 40 to 100, and I was able to get much more diverse populations for age groups, so I obtained 2 classes per grade, and I divided them up equally, and I ended up with a class of 7th graders, sophomores, seniors for each group. So regardless of the grade, there was always a greater improvement in the experimental group than the control group. So as you can see, 7th grade, for the control group, the mean improvement was 2.5, and in the experimental group, it was 12.6875. And similarly, the improvement for the control group for 10th grade and 12th grade were both very small, and then in comparison, the improvement for the experimental group was much greater than that, and that goes to show why it is statistically significant. So just like session 1, this is the t-test for session 2, and I calculated a p-value that is very, very low, and it's even lower than the first one. And this suggested that I could assume my alternative hypothesis again, that the experimental group's improvement was greater than the control group. Because both sessions utilize the same conditions, I combined my session 1 and 2 data for a holistic analysis, and just like the other ones, the experimental group had a greater improvement than the control group, and I made a visual for this one so it was a little easier to see, and I was able to get a p-value that was even lower than the other tests, and this is mainly because I had a greater sample size. My data suggests that there's a possibility that there's a very likely possibility that jazz music improves the visual spatial performance in Iolani's upper school students. However, it's important to acknowledge that I was unable to randomize my population. In future experiments, this would be ideal, but it was just not realistic for my situation because of COVID. But for further research, I would utilize randomization as well as the types of jazz I use in this experiment. It would even be worthwhile to experiment with different genres, both lyrical and non-lyrical. So, yeah, it would also be beneficial to experiment specifically with the music that individuals listen to while they do homework. And yeah. And however, reflecting on my experiment I have done, I am extremely proud of how it went, and I am especially happy with the results. And because my data had a consistent outcome, I can think of many ways to implement my findings. But one simple thing that we can all do is just listen to jazz, and not only is it relaxing, but it's truly an art that's worth being exposed to. I have so many people to thank who made this project possible. Thank you, Dr. Chan, especially for letting me take this course and for supporting me throughout the whole year. This was really such a special opportunity to take honors independent research. And for all of you who are interested in taking this course, I would definitely recommend it because it's such a special opportunity. And yes, it's definitely a lot of work, but everything flies by so quickly if you truly love your topic. And music is my passion, and I wanted to find a way to combine that passion with a way to help my school community. So, that being said, I'm so glad that I took this class because I was able to do both, and I'm very happy to do so. Thank you, Dr. Lei, for being my mentor and helping me a lot with a lot of the beginning stages of my study and helping me think of the idea in the first place. And thank you, Dr. Chin, for supporting my project by allowing me to run my experiments in school. And also, thank you, Dr. Chan, again for letting me use the wet lab. Also, thank you, Dr. Alfredo Campos, for advising me and helping me design a thorough experiment. Also, thank you for giving me access to the test for free. And also, huge thanks to Miss Nire for taking the time to teach me statistics in such a short amount of time. I wouldn't have been able to do any of my analysis without your help. Another huge thanks to my team of teachers who were so generous to let me come into their classes to test students. Ms. Frith, Ms. Finn, Mr. Greenhill, thank you for giving up your class time for me. And also, thank you to all the students who participated in this study. You guys are the best, and the data you guys generated was amazing, and it was all significant. I also want to thank my family, friends, and classmates for all the support as well. Lastly, I would like to thank all of you for joining me today. I appreciate everyone who has taken the time to listen to my talk. Feel free to unmute and ask any questions you may have. Other than that, this concludes my presentation. Thank you.